Titration is an analytical chemistry technique used to determine a solid's concentration in a solution. It involves gradually adding a titrant, a solution of known concentration, to a known volume of the analyte with solution of unknown concentration until the reaction reaches an endpoint, often indicated by a color change due to an indicator or by reaching a specific pH value. The volume of titrant required to get the endpoint allows for the calculation of the analyte's concentration using stoichiometric relationships. Titration is widely utilized in various fields, including pharmaceuticals, environmental testing, and also in food chemistry, for its precision and reliability in quantitative analyses.
The measured volume of the analyte solution whose concentration is unknown is placed into a clean aluminum flask. Second step, a few drops of an appropriate indicator which will show a visual change at the endpoint are added to the analyte solution. For the third step, the titrate, a solution of known concentration, is slowly added from a burette into the analyte solution while continuously stirring the mixture. The fourth step, as the titrate is added, the reaction between the titrate and analyte progresses towards completion. For the fifth step, the addition of the titrate is stopped when the indicator signals that the endpoint has been reached, usually through a distinct color change. For the sixth step, the volume of titrate used is recorded. And for the last step, using the known concentration of the titrate and the recorded volume, the concentration of the analyte is calculated based on the stoichiometric relationship of the chemical reaction involved. In a direct titration, a titrate is added straight to the analyte solution until the reaction achieves its endpoint, which is usually indicated by a pH value being reached or by an indicator-induced color change. This is a simple approach that is frequently employed in situations where there is a direct and fast response between the titrate and the analyte, such as redox or acid-base titration.
Second is back titration. Concentration of the analyte may be calculated using the difference between the amount of the first titrant and the amount of surplus reagent found by the second titration. When determining a substance concentration in an insoluble matrix or when the analyte is volatile, back titration is very helpful in complicated processes.
Titration is a method used in pharmaceutical business to determine the concentration of chemicals in a sample. It is useful in finding out the quantity of calcium ions present in the toothpaste, as the amount of calcium ion present is accurate. Calcium carbonate is a vital component of toothpaste, known for its abrasive qualities and significance to dental health. And it is important to determine the amount of calcium carbonate in the toothpaste to guarantee that the toothpaste calcium carbonate content fit the predetermined criteria. Other than that, it is to ensure the right quantity of calcium carbonate used to preserve the consistency and effectiveness in the product formulation. And finally, to allow the standard means set forth by regulation on toothpaste composition.
Hi, Assalamualaikum everyone. So in today's video, I'm going to talk about the methodology of experiment, how to determine CaCO3 in toothpaste. In this experiment, we have a total of 18 steps. Now, for the first step, of course, before using any analytical balance, we have to zero scale in order to remove any unwanted weight from dust or other buildup and to have more accurate results. And then, 125 of Erlenmeyer, or also known as conical flask, were put on the scale. Next, 0.5 grams of toothpaste were weighed using spatula directly into 125 ml conical flask. The weight value was then recorded. And then using 10 ml of graduated cylinder, 10 ml of distilled water was added to the toothpaste. A 10 ml volumetric pipette was utilized exactly 10 ml of 0.1 mHCl, which is hydrochloric acid, into the water solution. Now, stir bars were added, heat and stir for 5 minutes on a hot plate. After that, we need to remove it from heat and let it cool down. After the solution has cooled down, a few drops of phenolphthalein indicator were added.
Then, the titration 0.10 molarity sodium hydroxide in burette was starting to be added slowly. 11. The pH was checked after every 1 ml of titrant was added. 12. Both the initial volume and initial pH were recorded. 13. When the solution starts to turn pink but return to transparent and clear after swirling, slower drop spurts were added. After endpoint was reached, the final pH and volume was recorded. 14. Titrate was continued, added an additional 4 ml of titrate. 15. Again check the pH after 1 ml has been added. 16. This experiment was repeated 2 more times. This will give a total of 3 separated titrations. 17. The whistles were disposed of in the large beaker provided. Do not dispose of them down to the drain. 18. The leftover NaOH solution was left in the burette after use.
According to the results, there are 2 samples used in this experiment. Sample 1 used 20 ml of hydrochloric acid, while sample 2 used 30 ml of hydrochloric acid. Sample 2 has 2 data along with the average of both data. Sample 1, the weight of the toothpaste is 0.48 gram and the initial volume is 32.52 ml, while the initial pH is 1.98 and the final volume 39.5 ml. Thus, the final pH is 9.97. So the total volume is 6.98 ml and the volume hydrochloric acid reacted with the toothpaste is 3.02 ml. Therefore, the moles of hydrochloric acid reacted is 3.02 exponential to negative 4 mole. For the first data of sample 2, the weight of the toothpaste is 0.43 gram. The initial volume is 39.5 ml. The initial pH is 2.51 and the final volume 44.81 ml. Therefore, the final pH is 8.02 and the total volume is 5.31 ml. Thus, volume hydrochloric acid reacted with the toothpaste is 4.69 ml and the moles of hydrochloric acid reacted is 4.69 exponential to negative 4. And for the last data of sample 2 is 0.47. For the second data in sample 2, the toothpaste weight is 0.47 gram, the initial volume is 42.5 ml, the initial pH is 2.46, and the final volume is 45.61 ml, the final pH is 7.94, total volume is 6.21 ml, and volume hydrochloric acid reacted with toothpaste is 5.08 ml. Therefore, the moles hydrochloric acid reacted is 5.02 exponential to negative 4. Lastly, for the average of both data in sample 2 is by we add both data and divide it by 2. And therefore, we got the toothpaste weight is 0.45 gram. The initial volume is 41 ml. The initial pH is 2.46. The final volume is 45.21 ml. The final pH is 7.98. The total volume is 5.676. The total volume is 5.76 ml. The volume of hydrochloric acid reacted with toothpaste is 4.89 ml and the moles of hydrochloric acid reacted is 4.89 exponential to negative 4.
In the experiment to determine the concentration of calcium carbonate CaCO3 in toothpaste using back titration, the observation of a pink color when 51.24 ml of sodium hydroxide was added indicate the endpoint of the titration, signifying the neutralization of excess hydrochloric acid. This result suggests that the reaction between the HCl and COCH3 in the toothpaste sample has been complete, allowing for the accurate determination of the concentration of CaCO3. However, it's correct to consider potential sources of error and take necessary precautions. Possible error could arise from non-accurate in measuring the volume of the solution or variation in the strength of the NaOH solution. Precautions to mitigate this error include calibrating the equipment carefully, in conducting multiple trials for consistency, and using standardized solution. Additionally, ensuring proper mixing and reaction conditions, such as maintaining a constant temperature, can exchange the reliability of the result. Overall, despite potential error, the experiment demonstrates the effectiveness of back titration in accurately determining the concentration of CaCO3 in toothpaste, with carefully attention to procedural details and precautions. We can say that this experiment highlights the practical application of back titration in analytical chemistry and its role in ensuring the quality and effectiveness of everyday consumer products.
In conclusion, the experiment to determine the concentration of calcium carbonate in toothpaste using back titration proved to be successful. By adding excess hydrochloric acid to the toothpaste sample and subsequently titrating the unreacted acid, with sodium hydroxide, they were actually able to accurately determine the concentration of CaCO3. The observation of a pink color change, indicating the endpoint of the titration, provided a clear indication that the reaction has reached completion. While potential sources of error exist, such as inaccuracies in measurements of or variations in solution strength, precautions were taken to minimize this error. Overall, the experiment showcases the reliability and effectiveness of back titration as a method for analyzing the composition of toothpaste, ensuring quality control and consumer safety.